All right, thanks for checking in. I realize there's some errors in the video, so I'm just going to talk over the video real quick. So we are talking about, once again, special parallelograms. And our parallelograms, we're going to talk about the special ones are a rhombus, rectangle, and square. So the first shape we're talking about is a rhombus. So if you take a look at our first figure there, notice that we have all sides marked congruent. And when we take a look at the other properties, now you're going to notice over where it talks about a rectangle, this first property is actually true for any four-sided shape. Okay. And these properties, these first six here, are for only parallelograms, except for that first one. So because we know that there are parallelograms, we have opposite sides congruent, opposite sides parallel, opposite angles congruent, diagonals bisect, adjacent angles are supplementary. And remember that combination of these two, meaning that the there's one pair of sides is congruent and parallel. So rectangles have these two extra properties here, and rhombuses have these three. So if we look at a rhombus, we know that all sides are equal, and we know that when we draw the diagonal in from corner to corner, it's going to bisect the angle. So it's going to create these two congruent angles, and since opposite angles are equal, these four angles are actually going to be equal. That's also going to be true when we draw in the other diagonal. So when we go from corner to corner, okay, we're going to cut these four angles in half, and well, really two pairs of angles in half, and all four are going to be equal to one another. And the last property of a parallelogram is that when the diagonals meet in the center, they're going to form right angles. The diagonals are perpendicular to one another. Okay, so the three properties for a rhombus that you need to know: the diagonals bisect the angles, all sides are congruent, and the diagonals are perpendicular. For a rectangle, we have all right angles, so all angles are equal, or we could say that the consecutive or adjacent sides are perpendicular. Is another way to kind of get that through. And the other property is that the diagonals are congruent. So when you draw the line going from corner to corner here, and also draw on the other diagonal from corner to corner, that these two lines are equal. And because it's a parallelogram and they bisect each other, we're actually going to create four equal parts here. Okay, so the diagonals are congruent and they bisect, so these four parts are going to be equal to one another. The last shape is going to be a square. So squares have all right angles. All right. And all equal sides. And when we draw the diagonals in from corner to corner, remember that since it's a, now, one thing to keep in mind, since it has four equal sides, that also makes it a rhombus. And since it has four right angles, it also makes it a rectangle. So when we draw the diagonals in, they're going to bisect these angles, which makes each angle 45. And because they're the diagonals are equal in a rectangle and perpendicular and also bisecting, we are going to get all four parts equal. We're going to get 90-degree angles, and that'll be our square. So what I'm asking you guys to do today is to go through and basically work on these questions down here. So if you take a look at number one, now if you get stuck on a question, feel free to ask a neighbor, or if you can't do that, just skip it for now and we'll go over it when I see you guys next. Now for 1A, what we're going to do is determine what type of shape it is. So when you're looking at it and you can see here that it has these two sets of sides parallel and congruent, okay, then you should be able to name the shape based off this additional marking of a right angle. So if this angle is 90 degrees, remember the angle next door to it has to be supplementary, so that makes this 90, and the opposite angles are equal, so we get all 90-degree angles, making this a rectangle, excuse me. Now, since one pair of sides is congruent and parallel, it's going to be a parallelogram, and because it has a right angle, that makes it a rectangle because it's a parallelogram with a right angle. This next shape we can see has all the sides and all the angles marked congruent, so that's going to make it a square, and we can just justify it by saying all angles and sides are equal. The last shape over to the right there you can see the four sides marked congruent. So that means it's going to be a rhombus. And we can just justify that by saying that all sides are congruent. All right. Now, in number 2, we always want to start by identifying what type of shape this is. So as you're looking at it, you can see the 4 markings on the sides. So then we know it's a rhombus. Okay, so that's going to be important. And we know that that's the shape first. So now we can bring up those properties in our mind about what we can use to solve. Now, if we go back up to the properties of a rhombus, the ones that are important here are going to be the fact that the opposite angles are equal, the diagonals are going to be bisecting the angles, and the diagonals are perpendicular, meaning they make 90-degree angles again. So when we bring it back down to question 2, we are going to know that the diagonals, when they meet in the center there, are going to form right angles. So we'll already know that angle 4 is 90 degrees just because the diagonals are perpendicular. Also remember the diagonals are going to bisect the angles and that opposite angles are equal. So we'll know that both of the angles down here are 68. And since the angles across the way and the opposite angles are equal and also bisected, that means angles 2 and 3 are also going to be 68. So we know angle 3 is 68 now, and angle 2 is 68. And angle 1 is kind of neat here, that it's contained in a smaller right triangle. And since we know that the angle in the center here is 90 and angle 2 is 68, we can figure out the measure of angle 1 because we know that all angles add to 180. So 90 plus 68 is 158. And then we can take 158 away from 180 to figure out the measure of angle 1, which is going to be 22. Now, there's an extra way to do this, which is that if we have a 90-degree angle in a triangle, the other 2 acute angles are going to be complementary. They're going to add to 90. So we can just take 90 and subtract away the angle we already know, which is the 68 from angle 2, and that's another way to get the measure of angle 1. And so 90 minus 68 is also equal to 22, and that's another way to do this. All right, have you guys work on 3 and 4 the same way. And for number 4, just remember anytime it gives you the shape, you can draw it. So off to the side, draw yourself a rectangle, okay? Make sure we're labeling correctly. We're going to pick a corner, okay? Call that one of the first letters you see, so H, okay? So here's H in the top left, and then we're going to go around in a circle here to the left and label the rest of the letters H, I, J, K. Now, it talks about the fact that we have the H, J, and I, K, so we would draw those lines in. We'll notice that those are diagonals, and remember the diagonals are congruent. So set up your equations and solve for on your own here. I'll have you guys work on number 5 as well. And then for number 6A, keep in mind that it's a rhombus, and the diagonals once again are perpendicular. So we can use this small triangle here where those angles are contained, and we'll be able to figure out the measure of those angles using the fact that the angles of the triangle add to 180. Over on the right for B, remember it's a rectangle, so the diagonals are equal, and because it's a parallelogram as well, they're going to bisect, so these 4 parts are equal. And let's see if you can create an equation and solve for B now. All right, number 7, little bit trickier, but you should be okay with that. All right, but the ones we really want to take a look at here are 9, 10, 11, and a little bit of 12 and 13. So let's look at letter number 9. Now let's draw a picture first. So we have a rectangle, and we know that the width, right, which we don't know what it is, but the length is twice of that. So we need to know the width first. So we'll call W our width, and if the length is twice that, that means it's going to be 2W. Now we're looking for the perimeter, so remember that perimeter just means add all the sides. And so if you go ahead and make your equation now using your side lengths, what should you get? In question 10, Keep in mind we have a parallelogram for ABCD to the left, and on the right we have a triangle. We're looking for the measure of angle BDC, which is over here, and we know angle E is 105. So use your properties to help you out here, but one big thing is on the right side of the shape, there's not only a parallelogram, there's also a triangle hanging out over here. And if you look at your directions in the question, we know that BD and BC are equal. So what type of triangle is it, and how can you use that to figure out the measure of angle BDC? So give this one a shot as well. Now, number 11, this is a little bit trickier. This is going to pull for some older stuff from 7th and 8th grade. But let's take a look at a diagram first. So if we have a square, okay, we know that the side lengths are 10, so go ahead and mark that down for ourselves. All right, and we have, and we're looking for the length of the diagonal. So when you draw the diagonal in, just one of them, you'll end up making a right triangle for yourself. So if you remember the theorem that helps you get sides of a right triangle, the Pythagorean theorem, hopefully, a squared plus b squared equals c squared, that a and b are the legs and c is the hypotenuse. So the legs are both 10 here. So we can go ahead and plug in and do 10 squared plus 10 squared is equal to c squared, or x squared here. And then if we combine like terms on the left, we're going to get 200. And to simplify this, we're going to use the calculator to do a little trick here. So on the calculator, we're going to press menu, and then you can just press the numbers 2, 3. Now don't do this for the start here, but 2 is number, okay, not 3. So menu, if you make a mistake, just hit escape there. 2 or 3, 2 for number, 3 for factor. And you're just going to type the number that's inside the radical here and hit enter. And these are the prime factors that actually multiply to give you 200. And the way we're going to teach simplifying radicals is by doing prime factorization. So if you type these numbers in, 2 times 2 times 2 times 5 times 5, you'll notice that they give you 200. So what we're going to do is we're going to write down a radical. To get x by itself, we'd have to take the square root of both sides. And instead of writing 200, we're going to write down the prime factors of 200. Now, when we're taking the square root, we're looking for pairs of numbers because 2 times 2 is 4 and 5 times 5 is 25. We're just going to take the square root of those two groups. So the square root of 4, remember, is 2. So from each set of numbers, we're going to move one number to the front. So 2 times 2 is 4, the square root of 4 is 2. 5 times 5 is 25. The square root of 25, let's bring one number out front when we take the square root, is 5. And we're left with a 5 times 2 outside and just a 2 left in the radical. So when I write my final answer, I'm going to multiply the numbers outside the radical together. 5 times 2 is 10. And then we're left with a square root of 2, or a radical 2, because that's the only number that's left in the radical. We didn't have any extra parts there, or extra pairs, so that's our answer. Okay? So see if you can work on the rest of these questions, and if you get stuck, that's fine. Just skip it, or ask someone next to you. Ask someone next to you first, and then if you get stuck from there, skip it, and we'll take a look at it when we come back tomorrow. All right? So let me know if you guys have any other questions. Hopefully that makes a little bit more sense in terms of the special properties. We'll go through answers tomorrow. All right? And I hope you guys have a great day.